Okay, this is applications of matrices, note inverses. So sometimes we can use matrices to solve problems involving real-world type applications. So a common one is systems relating to economics. So things like if you want to do profit and loss, prices, markups. But basically anything that you can imagine that would involve carrying out the same sort of operation on multiple things, well, we can use matrices to simplify that. So when we're doing these next activities, there are some important things to remember. If you convert your system in a matrix, check what you place in rows and columns. So the operations you carry out on them will rely on you having done this first critical step correctly. So if you get your columns and rows mixed up, it'll ruin the multiplication. If you need to multiply, have you set your matrices up such that the dimensions allow multiplication? So for example, it would be no good to have be multiplying a 3 by 2 by a 3 by 2. It would need to be a 3 by 2 by a 2 by 3, remembering that the two middle dimensions are the ones that allow us to multiply. So 3 by 2 times 2 by 3, the two 2's that I set in the middle allow us to multiply. And always check that the answer seems reasonable, always, every time. Let's have a look at an example. So example 1, a second-hand bookstore sells textbooks at a markup of 50%. The table shows the amounts they paid for old textbooks during the past academic year. So in semester 1, the business textbook was $940 and semester 2 was $980. So organise the purchase costs into a cost matrix with each row representing a subject. Okay, each row representing a subject, well, the subject is business, and columns representing semesters. And you can just see here, this is going to be obviously just translating our numbers in. But it's important that sometimes there'll be maybe a square matrix and it won't necessarily be obvious which way we're doing it. So let's have a look. Okay, well, you can see our cost matrix is, I'm just going to hit reveal solution. So we've literally just copied our numbers in here, like that, straight from the table. Question B. B was organised the revenue that will be generated when they managed to sell all the textbooks into a revenue matrix. Okay, well, a markup of 50% means they'll be sold at 150% of the prices, so you need to multiply this matrix by 1.5, and that'll give us this. Question C. Complete the profit matrix, or how much we're selling them for. Profit is equal to the sale price minus the cost price. So you bought the first semester 1 business textbook, you sold it for $14.10, and then you had bought it for $9.40. So the difference in those two numbers should give us the profit in that box there. And similarly with all the other textbooks. How much profit would the bookstore have generated from the sale of all of these textbooks is question D. So once you've created your generated your profit matrix by subtracting your sale price minus your cost price to give us our profit here, well, let's sum all of those elements together to get $5,270. Example 2, the previous season of the local cricket comp. The winner is the team with the highest number of points at the end of the season. Wins were worth 8 points, ties 4, draws 2, and losses were 0. So in cricket, a tie is when both teams get the same amount of runs, and then a draw is often when the match is not completed, so when it rains or something like that. So we can see the number of Darwin darts have 6 wins, 2 ties, 1 draw and a loss. So we could just drop this straight into our matrix here, representing the wins, ties, draws and losses for each of the 6 teams. We'll call that matrix A. Organise the point system into a column matrix B. So our points, remember, were 8, 4, 2 and 0. So we put them in here, 8, 4, 2 and 0. We'll calculate each team's total points for the season by finding AB. So we can go ahead and do that. We can use technology to do that. You can plug that into your calculator, but I suppose the really important thing to think about is let's interpret our answer here. When we're doing matrix multiplication, We were told to organise them into a column matrix B, but what if we weren't told that? How would we know? Is it meant to be a row matrix like this, or is the column indeed correct? Well, let's think about it. This first row across here are the numbers of different results for the Darwin darts. 6 wins, 2 ties, 1 draw and a loss. So here's Darwin darts across the first row. And we know the matrix multiplication is row times column. So the Darwin darts have 6 wins and there are 8 points for the win. So you can immediately think, oh, that's 48 going to be 48 points. And the next part of matrix multiplication is we multiply row 1 by column 1, and that will give us this first output result here. So 48 points from their wins. They have 2 ties, and each tie gives you 4 points, so that's 8 points. And in a matrix multiplication, we sum these together, we add them. So we're going to plus 1 draw and 2 points for a draw, it's 2 points, plus 6 losses and 0 points for a loss. So when you add those together, what we should have in our first row, just a single column this time, is Darwin darts. What are their total points for the season? Which team won the competition? The question for that would be, well, once we've gone ahead and done this multiplication, which of these 6 values is the largest number? And then we're interpreting that as, well, that's the team that has the most points from the season. Let's have a quick look. You multiplied 48 points plus 8 points plus 2 points, that gives you 58 points. And as we read down the column, we'll see the team with the most points is 72 points. That team was the Sydney Sickies. Question E was the number of matches each team played. So that was just the total number of wins, ties, draws and losses. That's just counting across here, which should be the same no matter which one you look at. Each team has 15 wins. And if every team, F is a bit of an extension question, well, how many matches there were in the whole competition? And we can actually use some combinatoric theory to answer this question. Every team, there are 6 teams and each team plays 15 matches, but you don't get to play, if I'm playing you and you're playing me, we don't get to count that as 2 games. So you're going to divide it by 2. And the total number of matches was 45. Okay, so that is applications of matrices. You can go to the module now and have a go at applications of matrices. Good luck.